Okay, so today we're going to be continuing with sequences, and we'll be writing our own. So let's take a look at this. This is section 9.1. It's called sequences, but as of the last section, you were given an equation and plugging in numbers to get whatever the nth term is. Today we're going to be writing our own expressions. So let's get into it. What I would like you to do is we'll try to figure out how to write an expression for the nth term, a sub n. All right, so just keep in mind, generally we have the arithmetic sequences, where if it looks like every term is going up by a number, this is like you add or subtract to get the next term, you're going to be having something like this, like 2 times n or something like that, 3 times n, whatever it is, and then we could always add or subtract another number. Sometimes we might even have a geometric sequence. And with geometric sequences, you might have to be multiplying by a certain number. So it might be something like maybe n squared or something like that. Generally, what we do is we look for an arithmetic sequence and we try to figure out what this formula is. We'll be learning more about geometric sequences in the future. So let's get started. Let's take a look at 1, 3, 5, and 7. And this is the first term, this is the second, this is the third, and this is the fourth. So what you want to do is try to figure out what do we do with 1, 2, 3, and 4 to come up with 1, or come up with 3, or 5. So this could be a little bit tricky. It's almost like a puzzle. But I know 1 squared is 1, 2 squared is 4, 3 squared is 9, so squaring doesn't look like it's going to work. But we are going up by 2 each time. So if you recognize an arithmetic sequence, let's multiply by 2 and then adjust it. So to get the first term, 2 times 1 is 2, subtracting 1 gives us 1. To get the second term, 2 times 2 is 4, minus 1 gives us 3. The third term, 2 times 3 is 6, minus 1. So that's how we come up with these formulas. All right, let's try the second one. What about 2, 5, 10, and 17 for the first term, second, third, and fourth? Now this doesn't look like an arithmetic sequence, so let's see if we can figure out something else. Well, right away I could see 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. 3 squared is 9, plus 1 is 10. So it looks like we're going to be taking the nth number, squaring it, and adding 1. It's just a matter of finding the pattern. How about 3, 7, 11, and 15? We have the first, second, third, and fourth. All right, so I could see that we're going up by 4 each time. So that means we're going to be looking at an arithmetic sequence, which means a sub n would be 4n. And to get 3, we'll do 4 times 1 and then subtract 1. To get 7, 4 times 2 minus 1 is 7. So that one was pretty easy. About D. We'll have 1, 1/4, 1/9, 1/16, and 1/25 for the first, second, third, fourth, and fifth term. Well, it looks like the top is always 1. And it looks like the bottom, well, I know 2 squared is 4, 3 squared is 9, 4 squared is 16. So 1 over n squared would be the answer for this. E. We'll have 2 over 1, 3 over 3, 4 over 5, 5 over 7, and 6 over 9. For our first, second, third, fourth, and fifth terms. So on top, I mean, to get 2, it looks like it's going up by 1, right? So plus 1 each time. So I'm going to say it's going to be n plus 1. That'll give us the top number, and that's independent of the bottom. So 1 plus 1 is 2, 2 plus 1 is 3. That takes care of the top. Now looking at the bottom looks like it's going up by 2 each time. 2 times 1 is 2, subtracting 1 gives us 1. 2 times 2 is 4, minus 1 is 3. So that's how you could figure that out. Let's try F. What if we had 1/3, negative 2/9, 4 over 27, and negative 8 over 81 for our first, second, third, and fourth terms. All right, so on top, I mean, 1 squared is 1. We have 1, 2, 4, and 8. Okay. Well, I know these are powers of 2, right? So on top we have 2, 4, and 8. But to get 2 for the second, I'm going to have to do 2 to the first. This is 2 to the second, but that's the third term. So if I do 2 to the n minus 1 power, that gives us, like look at the first term. 2 to the 0 is 1. 2 to the 2 minus 1 is going to give us 2. So that takes care of those numbers. You're just going to do one thing at a time. We also have a negative 1, right? On top, it looks like it's positive, negative, so it alternates. So what we could do is, let's put negative 1 here, but let's try to figure out what power we could do. Negative 1 to the n power, like for the first term, negative 1 to the first would be a negative term, but that's not what this is. So we can make it n minus 1 or n plus 1, because negative 1 to the 1 minus 1 is 0. That's positive. For the second one, negative 1 to the 2 minus 1 is negative. So it looks like that takes care of the top. It's 2 components, the negative and the 2. Now let's look at the bottom. Looks like 3, 9, 27, 81. Those are all power of 3. 3 to the n would give us what we're looking for. All right, maybe a couple more. We're on G. Let's say it's 1 plus 1/2. That's the first term. Second term is 1 plus 3/4. And then 1 plus 7/8. And then 1 plus 15 over 16. So to get the nth term in the sequence, I mean the 1's easy, right? Plus, well, it looks like the bottom are powers of 2. So I'm going to write 2 to the n, and that takes care of the denominators. But on top, that's a little bit trickier. So how can we get 1, 3, 7, and 15? Well, 1, 3, 7, and 15. So I know 1 squared is 1, 2 squared is 4, 3 squared is 9, and that's not really going to work. But I'm noticing that they're almost powers of 2. So like if you do 2 minus 1, you get this. 2 squared minus 1, 2 to the third minus 1, 2 to the fourth minus 1. So it's a little bit tricky to see that. but the way that we could write that formula is 2 to the nth power and then minus 1. Let's just check. So for the first power, 2 minus 1 works. For the second, it's going to be 2 to the second. 4 minus 1 is 3. All right, so it looks like that would be the formula. It's close. I mean, you could probably even get that from the bottom, but that's what I would pick. All right, and let's do one more. Let's say we have 1, 2. 2 squared over 2, 2 to the third over 6, and 2 to the fourth over 24. Let's try to figure this one out. So the top, it looks like powers of 2, but this is our first term, second, third, and fourth. So to get for the first term, I mean, this is 2 to the first, 2 to the second, but it looks like it's 1 power below. So I'm going to make the top 2 to the n minus 1. Because then on the third term, we're going to be doing 2 to the second. So that takes care of the top. The tricky thing is on the bottom. So it looks like we have 1, 1, 2, 2 times 3, that's 6, 2 times 3 times 4, that's factorial. Once you do a few of these, you kind of know what to look for. But that would be the formula I would use for this last one. All right, and there's one other thing I wanted to talk about today. What I'm going to ask you to do is write the first 4 terms of the sequence defined recursively and then we're going to use the pattern to write the nth term of the sequence as a function of n. So pretty much we're doing the same thing we've been doing, except we're writing it in function notation. So watch. Say the first term in the sequence is 25, and to get the next term, what you do is you do the previous term minus 5. So let's try to come up with a function with this. So let's have the number in the sequence, and then what the actual term is, and we'll see if we can figure out how to write a function rule from this. The first term is 25. To get the second term, 1 plus 1, right? We're going to take a sub 1 minus 5, 20. The third is going to be 15. The fourth is going to be 10. It asks us to write the first 4, so there we did. So now let's try to figure out how we could write a function rule for this. Function of n. And this does look like an arithmetic sequence. We are going down by 5 each time. But somehow we have to start at 30, right? So to get the first one, we're going to do negative 5n. Looks like if n is 1, this would give us 25. And then if n was 2, it would be negative 10 plus 30. So that's kind of what you're looking for. You're looking to come up with this on your own. It's an arithmetic sequence. That's how we do it. And one more. What if a sub 1 was 14? And to get the next term in the sequence, we do negative 2 times the previous. All right, so the first one's 14. to get the next term, a sub 2, we're going to do negative 2 times a sub 1. Then negative 2 times negative 28. Then negative 2 times 56. So let's try to come up with a function rule. And we're not going up by 14 each time. So that's, not something that we need to do. But we are doubling, right? So it's doubling. So generally when we're doubling something, we're multiplying it by 2, or we could even do like 2 to a power. That gives us a doubling effect. Now if we're starting at 14, and it was 2 to the n power, the first term would be 14 times 2 to the first would be 28, right? So that's here, but we want to be like over here. So let's make this n minus 1. 14. So for the first term, if n was 1, it would be 14 times 2 to the 0, which is 14. With 28, that would be the second term. 14 times 2 to the first. Looks like that happens. But how can we deal with the negative? If we put a negative inside here, let's see what that does. For the first term, it would be 14 times negative 2 to the 0. That's good. Second term, it would be 14 times negative 2 to the 1, or negative 28. Yeah, so it looks like we figured it out. And you could see my thought process and how this all works. All right, so it is a little bit tricky. Try to do it. It's fun once you could figure it out, but for homework, what I would like you to do is on page 626. I would like you to please do numbers 51 to 61 odd, 65 and 67. Have a nice day.